But in today's session, what we'll be doing is that I'm going to, discuss some selected actual past PSLE questions. Okay, meaning that remember I have mentioned in my past webinar, in the PSLE you will not see any pure recall question. Okay, they will not ask you what's the meaning of photostasis, what's the meaning of what's the difference between plant cell and animal cell, describe the respiratory system. You will never see such question, even though you must know, but the questions that they ask will be applied kind of questions, okay, where you need to apply the concepts that you have learned to day-to-day situations. Okay, so we will take a look at some examples. Right. So in today's session, I'm going to focus on physical sciences. Okay, what do you mean by physical sciences? Okay, physical sciences are in secondary school you learn, things like physics, right? In physics, biology and chemistry, it tends to be under life sciences, especially biology. But in your primary school, they combine everything together. But in general, you can divide the topics under physical sciences and life sciences, but not to worry too much about the differences, because in your primary science, they are divided into various topics. Okay, now let's start with the first question, okay? Now, this is a past PSLE question. I think last year or the year before, okay? I can't remember exactly which year. Yeah, let's take a look at this question. So all of you, I want to focus on this question, and I give you about 2 to 3 minutes to read through this question. Okay. Yeah, don't look at the answer. Just look at the question first. Okay, so Haziq used the setup shown to find out how the type of bulb affects the temperature of the surrounding. Okay, don't look at the answers yet. So I just want just focus on the question. Now, can you tell me? Okay, this is what we call an experiment question. It is what we call an experiment question. Now, remember, in an experiment question, what is the first thing that you should look out for? Ian? Can you tell us what is the first thing that you should look out for when you see any experiment question? Very good. Aim of the experiment, or more specifically, you need to find out what is the change variable. Okay, what is the change variable? And this change variable, you can find inside the aim of the experiment. Now, the problem is that sometimes some question, they did not give you the aim of the experiment very clearly. But in this particular question, they're quite nice. They tell you, right, like Haziq used the setup below to find out how the type of bulb affects the temperature of the surrounding. This is actually the aim of the experiment. Okay. Now, under the aim of the experiment, you will notice that they will always tell you what is the change variable. So in this question, can you tell us what is the change variable? Anyone can tell me what is the change variable or the variable change, or also known as the test variable? Okay, temperature of the surrounding is wrong. Okay, the answer is the type of bulb. Okay, the type of bulb. Type of bulb is the change variable. Okay, you see here, type of bulb. This is the change variable. Now remember, change variable is also known as the test variable, meaning what are you going to test? What are you going to find out in the experiment? So this change variable, so that means in the experiment, you must have different types of bulb. Okay, if your bulbs are the same, so you're not testing anything. Okay, so in this particular experiment, we want to find out the different types of bulb, how the different types of bulbs affect the temperature of the surrounding. Okay, now there can only be one change variable in an experiment, otherwise it will not be a fair test. Everything else must remain the same. It must remain constant, or it must remain fixed. Okay, we call this fixed variable. So if you take a look at the next part here, bulb R was lit up. Okay, he covered the box and recorded the temperature of the air in the box over a period of 10 minutes. So you can see here, this is a data logger. He uses the temperature sensor to measure the temperature of the air in the box over a period of 10 minutes. So you see 10 minutes is the fixed variable. Then he removed bulb R. So now he's changed the bulb. He changed the bulb and left the box uncovered for 15 minutes. Okay, before repeating the experiment with bulb S and bulb T. Okay, the results are shown below. Now, in an experiment question, it's very common that they give you the result of the experiment in the form of either table or graph. In this particular question, they give you a table. So you can see here the three types of bulb, and we know that the bulb is the change variable, bulb R, bulb S, and bulb T. And you can see here, this is the temperature of the air in the box at the beginning. Now, can you tell me what variable is this? What variable is this? Okay, this is called this is what we call the temperature at the beginning of the temperature at the beginning of the experiment. What variable it is? This is called the fixed variable. Okay. So this is temperature at the beginning of the experiment is a fixed variable or constant variable. Okay, it's also called the constant variable. All right. And okay, so after 10 minutes, if you take a look at it, the next part here, after 10 minutes, you take a look at the temperature. Now from 25 in bulb R, from 25 it goes up to 30 degrees Celsius. 25 degrees Celsius goes up to 33 degrees Celsius. For bulb T, 25 it goes up to 36 degrees Celsius. So next you must be able to analyze what is going on in this table. Okay, I always tell my students that you need to tell a story. From the table, you need to identify what story can we get from this table. Okay, so from it itself, you must know that you can see here the temperature increases most for which bulb? Temperature increases most for which bulb? For bulb T, right? Very good, Wanchi. So bulb T, temperature increase most. Okay, now somebody just now said, I think Hakim, you mentioned that the temperature of the surrounding, that is the change variable. It's not true. Temperature of the surrounding is what we call the dependent variable, dependent variable or the result of the experiment. Okay, yeah, this is the result of the experiment, right? Where they collect the data, right? They collect the data. Okay, this is what we call the result of the experiment. Okay. Right. So question, then they ask you fill in the boxes to show how the energy changes in the bulb. This is quite simple. So if you take a look at the answer here on the right side, okay, electrical energy from the bulb, and then it changed to light energy. Okay, the light bulb give out light energy as well as heat energy. So that's why when we have heat energy is given out, the temperature of the surrounding in the wooden box increases. Yes, Ian, correct. The temperature rises because of the heat from the light bulb. Okay. Now part B. Part A is quite easy. It's a 1-mark question. So all of you should get the answer. Now give a reason why Haziq left the box uncovered for 50 minutes before repeating the experiment with the next bulb. Now this is very important, quite a tricky question. Okay, so you can see here in this experiment, what happened here? He removed, after he used bulb R, he then removed bulb R and left the box uncovered for 15 minutes before repeating the experiment with bulb S and bulb T. Now, why do you think is the reason? Without looking on the right side, anybody can tell me? Wenchi, very good. To make the air back to room temperature, which is 25 degrees Celsius. Because if you continue immediately, you change to a new bulb and then you measure it, it will not be a fair test, right? You need to wait for the temperature in the surrounding to go back to 25 degrees Celsius. It is not about reliability, Ian. Reliability is when you repeat the same experiment. Here, we are referring to ensure that there is a fair test. Okay, so how to answer this question? To enable the air in the box to lose heat and thus decreasing the temperature back to 25 degrees Celsius. Okay, because if you do not remove the wooden box, okay, it will decrease, but it will take quite a lot of time. So when you open up the box, you let the heat escape, so you can decrease the temperature back into 25 degrees Celsius. Then you can start the experiment. So this is to ensure a fair test. Okay, part C. Which bulb, R, S, or T, should Haziq use to light up his room so as to reduce the energy used by the air conditioner? Now, if you have a, if you are in a bedroom, if you are using the air conditioner, you want the temperature to be cool as much as possible, right? Okay, there are different types of bulbs. Some bulbs give out a lot of heat. Some bulbs are quite cooling. So in this instance, they ask you if he wants to reduce the energy used by the air conditioner. Now, why must you reduce the energy used by the air conditioner? Anyone? Why must you reduce the energy used by the air conditioner? Why do you think so? To prevent global warming? Okay, to save electricity. Yes, very good, Inshira, to save electricity. Because if you use too much energy from the air conditioner, it takes lots of energy. Then you will, it needs more energy, and hence your electricity bill will be higher. Okay, so you want the air conditioning to be as efficient as possible, use as little energy as possible. So any lightings in the room which gives out a lot of heat, you want to ensure that the light bulb used does not give out too much heat. Okay, Wenchi, why is it $1 million? Okay, so you must help your parents to save to reduce the electric bill. Okay, so let's to answer back question C here. Why bulb R, S, T? Which bulb R, S, or T should Haziq use to light up a room so as to reduce the energy used by air conditioner? Okay, the answer is bulb R, right? If you look at bulb R, from 25 degrees Celsius, it increases only to 30 degrees Celsius. But the other bulb increase more, right? Only by 5 degrees, here increase by 8 degrees, and here increase by 11 degrees Celsius. Okay, so the temperature of the air in the box increase the least. Okay, increase the least when you use bulb R. So make sure you use the proper terms. Don't say that, oh, bulb R, the temperature in bulb R is, it is less. You cannot, it's lesser, cannot. You must use the right comparative words. In this instance, you are comparing with 3 bulbs, so make sure you say that it is the least, causing the air conditioner to use the least energy to cool the room. Okay, quite easy, right? So you think in this question you can get the full 3 marks? Okay, very good. Okay, let's move on. I have quite a lot of questions to discuss with all of you today. All right, next question. Okay, I give you 3 minutes to look through the question. Now look on the left side, don't look at the answer. Okay, the graph below shows the length. Okay, this is a past PSLE question, I think quite some time back, maybe 2013 question. Teacher, this was in my CA1. Yeah, yes, I know. Many schools, they like to use past PSLE question, especially the old ones. All right. The graph below shows the length of Daisy's shadow, how the Daisy shadows, the length changes over a period of time as she walks in a straight line near a street lamp at night. Okay. Now let's draw to give you a better understanding. Okay. Now let's say this is a street lamp, right? Let's say this is a street lamp. Okay. So you have Daisy here. You have Daisy here walking towards it. Okay. Walk towards this direction. And then this underneath it. Okay. Same person, Daisy. I know my drawing is not that good. Okay, and then you have walking away, walking away, right side. Okay. So you have the graph here. So when you see graph, very important, firstly, you look at the axis. What are the variable in the axis? So you can see here, the vertical axis is the length of the shadow, and the horizontal axis is the time in seconds. So this is time. The horizontal axis is the time. So 1 second, 2 second, 3 second, 4 second, 5 second, 6 seconds. And the vertical axis here is the length of the shadow. Okay, length of the shadow. So you can see here, as the time increases, the length of the shadow starts to decrease. Okay, length of Daisy shadow starts to decrease, and then at 4 seconds onwards, the length of the shadow starts to increase again. It starts to increase. Right? Now let's take a look at question number 1. Part A. Two properties of light cause shadows to be formed. One of these properties is light travels in a straight line. Okay, we know that light travels in a straight line is one of the property of light. Okay, let's take another property. Shadow is formed when light is blocked. Okay, shadow is formed when light is blocked. Okay, part B. Is Daisy walking towards or away from the lamp during period Y? Now let's take a look at period Y. Period Y. Now in period Y, let's see the graph. The graph is going upwards. The graph is going upwards, meaning that from second number 4 to the 6th second, the length of the shadow increasing. Okay, length of the shadow increasing. Okay, so if you take a look at this, you take a look at the example here. Okay, now if Daisy is walking towards it, now which part? Is it A, B, or C in which the length of the shadow is the smallest? Anyone? In which part? Where will the shadow of Daisy the shortest or the smallest? In the middle, right? Okay. When Daisy is right underneath the lamppost, the shadow will be the shortest or the smallest. Just like if we are standing outside in the afternoon, okay, 12 p.m. You can see that our shadow will be the shortest, right? Very small shadow. Early in the morning, our shadow will be very long. Okay, as the sun rises, the shadow will become smaller and shorter, and then in the evening, going towards the evening, our shadow will go back longer and longer. So in this instance, we can see that in period Y, okay, she must be walking away from the lamppost, right? Away from the lamp. Okay. So they ask you to give a reason. So Daisy is walking away from the lamp during period Y. Why? Because as time increases, the length of a shadow increases. So the time increases, you can see here, the length of the shadow increases because it is upwards sloping. All right. Now part C. Part C is the tricky part. Okay, part C is the killer part. Now, not many students can answer this correctly. Now let's take a look. From the graph, Ken concluded that Daisy was walking at a slower speed during period X compared to period Y. Explain how did Ken come to this conclusion. Some of you are wondering, teacher, how does his speed has to do with the graph? The graph only mentioned about the shadow and the time. Nothing mentioned about how fast he is walking, right? Okay. Now, if you take a look at the graph here, you take a look at this graph. Okay, part X, part X. Okay, let me draw something. Let me draw something. Okay, in part X, yeah, this is part X, right? Okay. Now, between these two blue lines, right, from part in part X, between the the first second and the third second, this is the length of his shadow, the change in the length of his shadow. But in part Y, you see in part Y, the length of the change the length of shadow is here, from here to here, right? So this is the change in the length of the shadow. Now, can you tell me in which part? Okay, in which part? Is it part X or part Y in which the change in the length of the shadow is greater? Part Y, right? So you can see part Y, the change in the length of the shadow. Okay, part Y is also 2 seconds. From 4 to 6 is walking 2 seconds. In part X, he's also walking for 2 seconds from first to the third. 2 seconds here, 2 seconds here. He also 2 seconds. So when both of them are walking for 2 seconds, then you can compare. Then it will be a fair test, fair comparison. So for 2 seconds, in part X, he's only covering the length of the shadow. The change in length of the shadow is only here. This part here. This is the length of the shadow. But in part Y, the change in the length of the shadow is greater. You can see from here to here, right? From here to here. So by looking at the change in the length of the shadow, you can conclude, okay, you can conclude that she is walking faster in period Y as compared to period X. Okay, so how do you answer this question? Okay, the change in the length of the shadow, okay, keyword here, the change in the length of the shadow is less in period X than period Y, given the same time period of 2 seconds. The red color here is important because you must compare when the time taken is the same. So in this instance, in period Y, 2 seconds, period X, 2 seconds. In 2 seconds, okay, in period X, she's walking slower. Why? Because the change in the length of shadow is less in period X compared to period Y. Okay? Understand, everyone? Who is still blur? Hamza, understand? Very good. Kaisara? Okay. Amy, you're still blur? Okay, no problem. You still blur later on. When I email you the recording of this webinar, you can review again. Okay. Ryan, you can see this is a past PSLE question, not that easy. The first two parts are quite straightforward, but the third part, even though it's only a 1 mark question, but it is quite challenging. So it is tricky. Some PSLE question can be very, very tricky. Okay, let's move on to the next part. Next question. Okay. I give you 2 minutes to look at this question. Look at this question. I think this is last year or 2 years ago question. Okay, let's take a look at this question. Sami conducted an experiment using the setup below. She placed 4 similar test tubes A, B, C, and D. Take note, the keyword here, the test tubes are similar. Okay, you can see each test tube has a plant, oil, and water, and the type of plant is the same. Okay, number of leaves also the same. Okay, so the test tubes are all the same. Okay, but the difference here, in A, you see the lamp 15 cm. In B, the lamp is 60 cm away from the setup. In setup C, instead of the lamp, there's a fan, which is 15 cm away. And in setup D, there's a lamp, there's a fan, which is 60 cm away. Yes, of course, this is a past PSLE question. If I'm not wrong, it's a last year's PSLE. Okay, so the graph shows the amount of water in the test tube over a period of time. So you notice here, this at the start of the experiment, the amount of water is the same. What variable do you call this? Okay, the amount of water is the same. What variable do you call this? This is the fixed variable, because at the start of the experiment, okay, the fixed variable, okay, the amount of water has to be kept the same to ensure a fair test before you can compare. Okay, so if you take a look at the graph, there's time here, and the vertical axis is the amount of water in the test tube. So you can see here, D decreases the least. The amount of water in D decreases the least, and the amount of water in A decreases the most. Okay, decreases the most. So part 1, explain why the different distances of light from the plant affects the amount of water loss. So in part 1, can you tell me which setup would you compare? Okay, in part 1, which setup would you compare? Would you use all the setup? Which setup will you use? Setup A and B. Very good. You only use setup A and B because in part 1, they are just asking you about the difference in the distance of the light from the plant. So only light from the plant. So you only use setup A and setup B. So setup A and setup B, you can see here everything is the same. The only difference is the distance between the lamp and the test tubes. Okay, the distance, the different the distance. So the question they ask you, explain why the different distance affect the amount of water loss. So you can see between A and, so let's compare only A and B. Okay, so this is graph B and this is graph A. So you can see here, you can analyze from the graph that the graph A, okay, which is this, the water loss is greater, right? Why? Because at the end of the experiment here, the graph decreases more than in B. In A, it decreases more than in B. It means that the amount of water left in the test tube in A would be lesser than in B. So it also means that the amount of water that is being absorbed by the plant is greater in A than compared to B. And then they ask you to explain why. What is the reason? First of all, you need to recall. Okay, what is the change variable here? Okay, what is the change variable? Number two, what causes what causes the plant to lose water? Okay, what causes the test tube here, the amount of water in the test tube to be decreased? So when we talk about light, straight away we recall that this is the topic on photosynthesis, right? Now let's recall photosynthesis. What happened in photosynthesis? Okay, plants take in carbon dioxide and take in water from the roots, right? And with the light energy, it makes food, right? It makes food. So you can see here, when the lamp is closer or nearer to the test tube, okay, the amount of water being absorbed by the roots is greater, right? So what can we conclude here? Okay, so the nearer the light from the plant, okay, the greater the light intensity, and hence the faster rate of photosynthesis, causing more water to be absorbed by the roots and hence greater water loss. Okay, so keyword here, firstly is that when you compare between A and B, okay, the nearer the plant from the light, the greater the light intensity, right? Okay, as the greater light intensity, what happens here? Faster rate of photosynthesis. When there's faster rate of photosynthesis, that means that the plant needs more water, right? So that it can make more food. Okay, since they have more light energy, hence more water is being absorbed by the roots and hence greater water loss. So that is why in setup A, the water loss is greater than in setup B. Okay, so that is the first 1 mark question. Yeah, it seems so long, but it's only one mark. Okay, part 2. Which variable, light or wind, has a greater effect on the amount of water loss? Give a reason for this answer. This is a very interesting question also. Now, can you, if you want to take a look at the result for part 2, which two variable or which two setup would you use? Would you still use A and B? Would you use, okay, can I use A and D? Cannot, because A got lamp, D is fan. Okay, why you cannot use A and D? Why you cannot use A and D, Mikael? Very good. Remember, when you are using A and D, okay, the one is lamp, one is fan. Okay, this is a change variable, and the distance is also different, right? So you cannot have two change variable. If you have two change variable, so you wouldn't know, right? What are you going to test? You need to, it has to be a fair test. In a fair test, there can only be one change variable. Okay? So what you need to compare is, you need to compare between setup A and setup C, or you can also compare setup B and setup D. Okay? You can make comparison with two. Okay, let's compare between A and C. Let's look at A and C here. A and C. Now, if you take a look at setup A and C, in setup A, it decreases more than in setup C. So, given the same distance of the lamp and the fan from the plant, okay, in setup A, the amount of water loss is greater, right? So we can answer here, which variable, light or wind, has a greater effect on the amount of water loss? So the answer is obviously is light. The light. Why? Because for the same distance, so very important that you put this, for the same distance from the plant, the setup with the light lost more water. Okay, the setup with the light lost more water. Likewise, also you can see compare between B and D. Let's take a look at B and D. So B and D here, you can see here that B loses more water. The graph is, it goes down more in B compared to D. So you can say here that in B, which is light, okay, for the same distance, it loses more water. Okay, right? Quite easy. Yeah, understand? Nashir? Don't understand. Nashir, you still don't understand? Okay, Nashir, which part you don't understand? Understand, huh? Okay, Nashir, no problem. Later on in class, if you don't understand, I can explain to you, next Saturday, all right? Okay, let's take a look at the next question. Okay, this is another interesting question. I think it's last year's PSLE question. Okay, Aziz used the setup below to study 4 types of spring. Spring P, Q, R, and S. Okay, 4 types of spring. So this is the setup. So this is setup here, and you see there's a tray here and the object. So you see the length of the spring, to measure the object, the length of the spring will be compressed. Okay, the length of the spring will be compressed. All right. So he placed objects of different mass on each spring and measured the length of the spring. The results are shown below. So you see the length of the spring is 20 cm. Okay, for in P, if you use spring P, it decreases for 1 kg of mass. You take a look here, 1 kg. In 1 kg, it decreases this amount. Okay, the length decreases this size. And for Q, decreases this much. And for R, decreases this much. So if you are to draw a line, let's draw a line. Okay, let's draw a line here. Okay, for 1 kilogram, P only decreases from this here to here. Right? Q decreases. Okay, let's draw here. This is a straight line at 20 cm. P decreases from here to here. Q decreases from here to here, and R decreases from here to here. S is about the same as Q. Now, using the same setup above, Aziz wanted to compare the mass of the 2 oranges below. Which spring PQRS is the most suitable for his setup? Explain. R? Okay, why? Why R? Okay, without looking at my answer, why R? Anyone can say? More elastic. You can see the difference easier. Yes. Okay, very good. If you take a look at these 2 oranges, you see the size is almost the same. Now, do you think there will be a lot of difference between these 2 oranges in terms of the mass? Do you think the mass will be a lot of difference? No, right? There's very little difference between the mass of these 2 oranges. So if there's very little difference, it means that the spring must be super sensitive, super elastic, so that you can tell the difference, right? So between P, Q, R, S, obviously R would be the most elastic. Why? Because it decreases the most. The length of the spring, it decreases the most. Okay, so the answer is spring R is most suitable. Why? Because there is small difference between the mass of the 2 oranges. Hence, the spring, which is the most elastic, which would enable the comparison between objects with small differences. Okay, quite an interesting question. Very interesting question, right? Okay, let's move on to the next question. Next question. Okay. Now, this is a multiple choice question. If I'm not wrong, it is a last year's PSLE. Okay, so this is a question on heat. Container in setup A, B, and C below are of the same size and thickness, but made of different materials. Now, what is the change variable here? What is the change variable? Can you tell me what is the change variable? The material of the what? Material of the, you must be specific. Material of the container. Okay, material of the container is the change variable. Very good. In setup A, you have made of glass. In setup B, made of iron, and in setup C, made of wood. So which graph correctly shows the temperature of the water in the three setup over a period of time? So you can see here, you can actually eliminate option 1 and eliminate option 2. Do you know why? Why you can eliminate option 1 and option 2? Okay, why you can eliminate? Because you can see here, the temperature of the water in A is constant. Okay, and in C here is constant. Now remember, even though glass and wood, they are poor conductor of heat, but they are not non-conductors. As long as material is, a material is a matter, solid, liquid, or gas, okay, it will still conduct heat away. So even though it may be, it may be glass and wood, which is a poor conductor, it will not be a straight line. A straight line means that the heat will be trapped inside, right? It doesn't escape, which is not true. Heat will still be lost after some time. Okay, I give you a simple example. Let's say you have a thermos flask, okay, where you use to keep hot water. So even after some time, even though it is a very good thermos flask, see after 1 year or 2 years, it will still, the water inside will lose it, will become, it will not become hot anymore, right? The reason being, heat will still be lost. Okay. Now, between these three, now which one will the heat loses the most? Obviously, iron, right? Because we know that iron is the best conductor of heat as compared to glass and wood. So the decrease in the temperature of water in setup B must be the most, right? In setup B must be the most. So you can see here, the only possible and the best answer, or the only possible answer is number 4, right? You can see here, because from 100 degrees Celsius, it decreases the most, okay, as compared to A and C. Okay, so you can see here, C is the poorest conductor of heat. Wood is the poorest conductor of heat between these three setup, followed by A. Okay, and the best conductor of heat is B. How do we know? Because the heat loss is the greatest. The temperature of the water decreases the most. Okay. All right. Next question. Let's move on to the next question. Okay. Now let's take a look at this. Now, have you seen this question before? This is last year's PSLE question, a 2-mark question. Okay. Now let's take a look. Now this is what we call application question. Okay, this is what we call application question, where there is no experiment and they ask you about day-to-day situation. Okay, so you can see here, when the air becomes very cold suddenly, the crack appeared on the pavement. Cracks appeared on the pavement. Okay, keyword here, let's take a look. If you see any application question, number 1, you take a look of all the items, all the all the terms and all the objects given in the question. So number 1 is the air become very cold suddenly. See here, the cold wind, right? It becomes very cold suddenly, and you take a look here, the soil here is warm. You notice here, the soil is warm. There are cracks, and these are pavements, right? You know, pavements are made of cement. Okay, now let's recall what topic are they testing you here? Okay, you always have to recall what topic are they testing you? Anyone? What topic? Under heat. Okay, good. Now, what concept are they testing you here? What concept? Under heat, there's many concepts. Okay, there's many concepts. Yes, under hit the concept of expansion and contraction. So we know that when when it is cold, okay, temperature, okay, or matter expand when it gains heat and contracts when it loses heat, right? So when there's a cold wind here, so it causes the pavement here to contract. But if you see the bottom part here is a warm soil, right? The warm soil will cause an expansion. Okay, will cause an expansion. So you have expansion and contraction. So there is different, there's tension in the pavement, right? The above, the top part here, cold wind, it causes contraction, and the bottom part here, it causes an expansion. Okay. So how to answer this question? Explain how the change in temperature, keyword here, the change in temperature, cause the pavement to crack. So the cold wind causes the upper part of the pavement to lose heat and contract. Okay, keyword here, you need to mention about lose heat, lose heat, right? Because when you talk about expansion, heat expansion, and contraction heat, you always have to talk in terms of heat loss or heat gain. But for contraction, heat is lost. So when heat is lost, okay, it contracts, while the warm soil at the bottom here causes the bottom part to gain heat and expand. So this expansion and contraction cause the pavement to crack. Alright, cause the pavement to crack. Now, of course, this may not happen over just a few minutes. This may happen over a long period of time. Continuous expansion, contraction over a period of time, and the top part and the bottom part, eventually, after a long period of time, causes the cracks to slowly appear. Okay, so this does not happen over a few hours or a few minutes. Okay, this can only happen over a long period of time. Okay. Maybe yes, maybe years, 2 years, 3 years, after some time, okay, it will crack. All right? You can see here it's a 2-mark question. Do you think you can score 2 marks if you are given this question? Can, huh? Okay. So I pray that all of you get A star for your science this coming PSLE. Okay? But you need to focus on your media exam first. Okay. Now let's take a look at the last question for today. Right. Now this is I think 2014 PSLE paper. Okay, Aisha filled a container made of wood with water at 60 degrees Celsius. So this question, there are 2 parts. I think I've shown some of you in class this question. All right. So Aisha filled a container made of wood with water at 60 degrees Celsius. The temperature of water remained 60 throughout the experiment. Now, what is the change variable here? Anyone can tell? Okay, anyone can tell what is the change variable here? Okay, very good. Distance y. So distance y is the change variable. All right, so you can see here distance y, 2 cm, 4 cm, 6 cm, 8 cm, 10 cm, and 12 cm. So there's a change variable here, and everything else remains the same. Like water here, 60 degrees Celsius. Okay, this must be the same. And this is the result of the experiment, 42, 36, and so on. So what is the relationship between the temperature of the air and distance y? This is easy. This is what we call relationship question. Okay, so as the distance y increase, the temperature of the air decreases, right? So this is very easy, 1 mark giveaway question. So what I want to you to learn from this question is that part A and part B, they are interrelated. Okay, this is what I want you to know. Please remember, if you see any kind of question in the exam, science and even maths, you must always take note that part A and part B are always related. If not, they will not put part A and part B in the same question. Okay, meaning that to answer part B, you need to refer to part A to give you the clues. Okay, you need interrelated means they are connected, meaning that you need to use the information or the clues in the earlier part so that you are able to answer the questions in the later part. Understand? Okay, so very important, because if you take a look here at part B, if you do not refer to part A, you will not be able to understand or answer correctly part B. Now they say that part B, animal H lives in the desert. It stands on the hot sand with 4 long legs. 4 long legs. So based on the findings above, explain why having long legs is an advantage for animal H. So I did some experiment in my class. So I covered part A, and then I asked the student, why does camel has long legs? So they give me many interesting answers. Some of them say that also that they can walk, walk in sand better. No, or if they are, if the camel fell into a quicksand or a soft sand, it can get out easier. Okay, so many different answers which are wrong if you are not able to answer correctly without looking at part A. So part A here, you can see here the clues given to you that as the thermometer here, the thermometer can represent the body of the camel, while the part Y here can represent the legs of the camel. So you can see here as the distance increases, the temperature of the air, so temperature of the air would be lesser. So meaning that it is much cooler for the camel's body here if it has a higher leg, right? Because remember in the desert, the desert sand is very hot. So if the camel's leg is short, okay, there will be more heat that travels to the body and you will feel warmer, right? Okay, so that is why you need to refer back in part A to give you the clue. So in part B, how to answer? Explain why having long legs is an advantage. So having long legs keeps animal H body away from the hot sand and hence keeping it cooler in the hot weather. Okay, so having long legs keeps animal H body away from the hot sand and hence keeping it cooler in hot weather. Okay, yes, that's right. To keep the animal, the camel cooler. Okay. Wenchi say, I wish I have long legs because Singapore is very hot. Singapore very hot, you just go into aircon, the aircon room, very easy. Okay. All right, so we have come to the end. All right, any questions and answer? No, so for this time period, I would not be able to explain many questions. So I hope that by explaining these questions, I try to cover as many topics as possible. Okay, so that you are able to see and understand, or you can expect the kind of questions in the exam, in the PSLE as well as your upcoming exam. You can see that a lot of the questions are applied, or experiments where it is not mere recall questions, but you have to apply the concepts that you have learned to the situation given to you. Okay, somebody asked, Ryan asked, teacher, why only went through 3 questions? Not 3 questions. I went through at least about 5 to 6 questions. Okay, now in class also we go through many questions. All right, Jovan asked, teacher, what's the difference between a fair test and reliable test? Okay, this is a very important concept that you need to know. Now anybody can answer, Jovan. What's the difference between a fair test and a reliable test? Anyone? What's the difference between fair test and reliable test? Okay, all right. So what's the difference? Okay, fair test and reliable test is a totally different concept. A fair test in an experiment is when you have only one change variable and everything else remains the same, fixed variable. So in experiment, it's very important for you to be able to make a conclusion from any experiment. You have to ensure a fair test. How to keep a fair test? You only have one change variable and everything else remains the same. Right? So you cannot have more than one change variable. Okay, let's take a look at the example, early example. Okay, let's take a look at this example here. Okay, I want to take a look at this, show you this example to illustrate what we mean by a fair test. So in this question here, Jovan, listen carefully. A fair test, it means that there is only one change variable. So in this experiment, The change variable here is the material of the container. Okay, so here in this instance here, this is made of glass, made of iron, and made of wood. So if you notice, everything else remains the same. Okay, the water here remains the same. The temperature of the water at the start is 100 degrees Celsius, remains the same. Okay, you see the size of the thermometer is also the same. Size of the container is also the same. Okay, so this is to ensure a fair test. Now, if we say reliable test, what is reliable? How to make the test reliable? Now, if we do a test one time only, can we say that it's reliable? Okay, for example, let's say we have a race, a 100-meter dash race. So if all of you are to run a 100-meter and I am to time you, and then suddenly, Jovan, you come up first. You are the first in the competition, okay, in that race. Can we say that you are the fastest? Can we say just by having one race, you are the fastest? No, right? Okay, what do I need to do to ensure that the result is reliable? So what I need to do is to have several races, right? I repeat the race. Okay, I repeat. So let's say after 3 races, if Jovan is still the winner, so confirm chop that Jovan is the fastest runner. Right not? Okay, maybe if I do only one test, what could be a problem, right? One test only could be probably my stopwatch is faulty. I could have made an error in measuring, right? So how to make the result more reliable is by repeating the experiment. Okay, so you have to do it. Yeah, you can do it at least 3 times. Okay, but in real life, you don't do it only 3 times. In real life experiment, you do many times, maybe 50, 100 times, okay, depending on the type of experiment. But for your level, you can just say use repeat 3 times, and then you take the average reading. Okay, you take the average of the result. Then you can find a reliable result. Okay. Okay, Zikang asks, all experiment must have change variable. Yes. Okay, change variable is also called the test variable. In any experiment, there must be a test variable because remember, in any experiment, you must have an aim of experiment. Okay, you must have an aim. Without aim, okay, you do not know what are you trying to find out. Okay, so every experiment there must be an aim and there must be a change variable. All right, everyone. Okay, last question. Wenqi, what if we have a question that we know the answer but don't know how to write it down? Okay, so Wenqi, if I get you correctly, is that if you see science question, in your mind, you think you know the answer, but you do not know how to answer. Okay, this is quite common. Okay, the thing is that some of you may not know the answering technique. Okay, you may not know the answering technique, how to answer. You see the question, even though you have a rough idea of what they're talking about, but you do not know how to express yourself. Do you feel that that way also, Wenqi? Am I right to say? Okay. Now, you cannot afford to be in that situation. Remember, in your science exam, you are under exam condition, under time limit. Okay, the time given to you in the science exam, it is 1 hour and 45 minutes. So you have to answer everything. You cannot leave any questions blank. Right? So you need to manage the time. MCQ, you must allocate about 40-45 minutes maximum. And then you need to move on to your open-ended questions. So if you have any questions that you do not know how to express, okay, one reason why you do not know how to express, number one, you do not know the concept. Okay, you have forgotten what are the concepts. That is why I told you that you must have the concepts at your fingertips, meaning that you need to learn, you need to remember, you need to use mind map to help you remember. Okay, you need to make notes. Okay, because during exam, all the concepts must be at your fingertips. Secondly, if you have the concept, you may not know how to express or apply. This one you need to refer to the 2 videos that webinar that I've recorded in the past. Number 1 is how to answer application question. Number 2, how to answer experiment question. Okay, in answering experiment question and application question, I show you very clearly what are the steps that you need to look out for. Okay, now the problem is that many students, they do not know how to, you do not know how to identify the problems, the key information in the question. So in that webinar, I've explained very clearly, if you see any experiment question, what you should look out for, what are the steps that should come into your mind. Okay, then with that, then you can answer more clearly. If you see any application question, for example, what should you write down? What are the steps that you should think about? Okay, so I understand it's not easy, but you need practice. You need practice. You need to be exposed to the different kinds of questions. Okay, so with more practice, with more efforts, with more exposure to different kind of question, I believe that you'll be able to answer any kind of science question. Okay. All right. Thank you very much. It's 11:03. Okay. Have a good day. Those of you who have classes in the evening, I see you later in class. All right. Bye bye, everyone.